And so welcome to this session. It is a strange idea, I know. I created this thing from my past experiences. So this is about making it easier to version the services, the public model or exposed by the services in distributed applications. And we will see this thing that I call the semantic driven modeling. This is because if you model your public model in a certain way that we will see, you will end up in a lot of advantages. And so welcome to my session. I am Raffaele. You probably know me from past edition of Codecamp. And I love being here. And I really hope to join you in person very soon, as soon as the COVID times are ending, luckily. And so, in usual distributed applications, we have a lot of strategies, different strategies to structure the backend. And for example, we have this cool new layer. This is the API gateway that many cloud providers offers to decouple the view that the clients have on the service side. And so we will focus just on the backend and not on the client side for the moment. And as soon as you go behind the API gateway, you see that there are many services. It doesn't matter if there is a kind of very strict microservice application or a different one. But it's correct to separate the concerns in different services because it's better for maintenance. The problem is that you end up in having a lot of versioning issues because you consume the pricing. You have a JSON that is structured with the public model for this service. And then you maybe want to consult the products, and you have another model, and blah blah blah. And you also know from DDD that you may have certain services that share a knowledge for the model and certain other not. And so this mismatch requires a translation that is often not that obvious. Also, this backend is not very nice to see in the diagram, right? So many people end up in saying, okay, let's put a queue. It's much better. We avoid having a mess on the drawing, but it's cheating, because even if you are using a queue, you end up in having the versioning issues inside each of JSON messages. And so this is not really a solution, because you push a JSON for the storage, and you may are reading from pricing certain other information, and you end up in having this. And from a slide, you cannot even understand who has dependency on other services. So it's a real mess. So let's say for today that we have two different models, just to simplify the goal. So this is the first one on the left, is the online order with many items inside one-to-many, the order lines. And this is very simple, maybe used in reports or in visualization for other purposes and transformations. And let's say that a few services use this one. And others, maybe the producer has this other view of the order. So the order has a one-to-many in order items, and the order item has many things, but the article is a one-to-one, and the customer is another one-to-one, and also address is a one-to-one in this. So it's very deep, a totally different shape, and so on. And when we came up in saying, not only have the versioning issue, but I also have to translate this model between each other, because otherwise I cannot consume the data. Maybe I am not interested in having all of this information here. Maybe they don't even fit. So usually the transformation issue is complex. Why? Because we have a server. The data can flow in this direction for a get, or can flow in the opposite direction with a post. And you always have a form of serialization. Let's stick for the moment with JSON, but many of the things that we are saying can be also expressed in other wire formats, of course. And this has versioning issues, right? Because this is the exact serialization for the order which is the public model used from this guy. And once we deserialize, usually we have a DTO with exactly the same of the public model here, and we deserialize this stuff, and we finally have some objects with the structure, with a graph. And then we have to convert this, and this conversion is not straightforward at all, because we have to map different graph structures, different data types, and also different names, which is quite difficult to do. And as soon as you want to post some data, of course, you have the opposite conversions, and then the serialization. And this other conversion is not straightforward at all. So it's not even similar to this one, because they can they are different in the way they are coded. So the .NET code is, I mean, it's duplicate. And then, so you basically have one big issue, that is the one that we have. So the client, which is in my slide, another service, by the way, not the client in the sense of in a desktop application or a web application or what else. It's just another service. Need to know what is the schema, let's say, so the shape of the order DTO, because otherwise we cannot deserialize the JSON order. This is a big issue, you know. And also we have a two-step. So we first deserialize, and then we convert, then we can use the data and go on and on. And I mean, this is the problem, the scenario for today. And if this client is a service and this server is another service, you end up in having also multiple conversion when you have chain of calls, because it may happen that one service has to call several others. So what is the idea behind semantic driven modeling? So my wish list is having the ability to rename classes and properties, to change data types, to even modify the graph shape, as you have seen before in the two models that I presented before. And also to, I want to direct deserialize or serialize from the JSON to the wire format to the target model, and vice versa. So I don't want to have the conversion step from object to object. I want to go straight from the JSON to the object, or from the object to the JSON, but with a different format. So basically, I don't want a plain serialization. I want to serialize into a different shape. I want to deserialize from a JSON into a different graph object. This is the point. There may be a restriction when you map different models. And these are very important, because, for example, the collections must be mapped to other collections. Of course, if you have some data that is inside an order item, and it's there is no collection on the other side, there will be a mismatch in terms of multiplicity, and you end up in some data will be overwritten, and this is, I mean, not acceptable. So you have to be careful about the difference among the models. But there are not so many restrictions, because you can do the opposite. So if you have some, for example, some data like name that you want to propagate on all the items inside the collection, well, why not? Maybe you are preparing a major changes in the model, where instead of the one-to-one, there is the one-to-many, and so you want to have duplicate data. That's acceptable. And also you should pay attention to lossy data type conversion. For example, if I want to convert a Boolean to a GUID, it's impossible. And so, I mean, there is something that you have to do. If you want to convert an integer to GUID, maybe you want to hook the conversion and to take place the conversion with a lookup table. And this is acceptable. I mean, it's good. But there are lossy conversions also, because if you convert a decimal to a double, you are going to have a lossy conversion. And maybe it's acceptable, maybe not. We will see how to deal with that. So what we want is this other model. So I have the server, it plain serialized to its own model. And so I have a JSON. And this JSON can be either deserialized straight into instances of a different model, or being serialized straight to the JSON that has the schema that belongs to the order. And this is so cool because you avoid the additional step of the conversion. You are doing straight deserialization, and even better, you don't have any knowledge of the order. Oh, well, we have some knowledge of the order because this transformation is done inside the client, but it's not using the type, the system type anymore. So you don't have any assembly you depend on. You don't have the DTOs you depend on. You just have some kind of metadata that represents, that tells you how the order is structured, and you can directly map into your own model. And we will see how this metadata is done. But the advantage is clear because you don't have any other knowledge about the order. You don't have to unload assemblies or use assembly load context or anything like that. You have a fast serialization and deserialization because my proof of concept directly code-generated the code to make this transformation. And is a standard JSON serializer. So it's a system text JSON. So it's nothing, it's not my own serialization. It's just a JSON converter that generate the code. And therefore, there is no need to restart the client, because if you have new metadata, we can regenerate the mappings and we can regenerate the conversion, and you are done. So in order to auto-build the mappings, so how can I know that a name must be mapped in something else? How do I know that a weight should be translated to load, for example? How can I deal with these mappings? The classical schema is too rigid. I mean, if we start from OpenAPI, we see the exact schema of the currently represented model, but we have no clue about the meaning, okay? And also with SOAP, it's the same. And if we go to the semantical web, and like RDF or schema.org and so on, it's very schema-oriented. So you have to lose a lot of time in preparing the schema, in instructing your mappings that exactly match from the source to the target. And this is quite boring. It also takes more time than doing the conversion manually, so it doesn't make sense. So we can instead express the data like concepts. So using the semantical meaning. Well, what does article mean? What does name mean? But pay attention, it's not just name. This is name in the context of an article. And this means that we can assign a concept to each class name and property name. And every time we drill down, navigating the graph of the model into a property, we inherit a context so that we can understand that this is not just a name. This is not a person name. This is an article name. And so I structured a kind of new abstraction that is conceptual based. At the very end, what we have is that we have the client and the consumer side that match. Oh, there is a little glitch on my side. You can basically calculate directly these mappings using this semantical meaning. And what we obtain is that we are able to either serialize or deserialize the JSON straight into the destination model using all the metadata that we will talk a little briefly, much better in a moment. So basically, we don't even have to map all the properties. Of course, we can omit some mapping, which is good, because if you think to GraphQL, for example, and we will have later a brief discussion about that. If you don't have the mapping, just the data isn't copied, and so you can just drop the data, and you don't, because you don't care about the specific field, because you don't need to. And this entire process take care of transforming, for example, the customer name that is inside an order line. The $sign is the nth item inside this collection. So the customer name is propagated here, and you see that the different structure is totally different, and even customer address state is mapped differently. And we also have data type conversion. This is very important, because we can think that the data type is not relevant in order to understand the meaning of the field. It's just a it's just a way to represent the data. So I have a view on the data under the form of double, and now here I have the decimal. Not all the representation has enough resolution to show it. So if I have a Boolean here, okay, the resolution is too low. If I have a double, the resolution is very high, but the decimal is more powerful. And so we have to take care, because in this direction, double to decimal, it's lossless. But from decimal to double, of course, there is a lossy conversion, because it follows the IEEE 754 representation of power of 2, and so it doesn't fit. And we also take care about the one-to-many and the one-to-one, and also there is this renaming properties that you can deal without any problems, and we will see how does it work. So before sticking to the slides, I want to focus a little bit on the demo, and I will show you some code. By the way, this is just a proof of concept, and I am still working on it, but the results are already pretty much interesting. And so there is a preparation phase where you have to calculate your metadata, no? Because when you compile an assembly, you have some data, and you also have the code with the metadata expressing your system types. And so similarly, every time we are at development time, and we know who is our other party that we will connect to, we can calculate this metadata. So most of the time, the metadata can be calculated at developer time. Anyway, if you want to move the calculation of the metadata at runtime, you're free to go. I mean, there is nothing preventing it. So the preparation phase is basically something that we will see in a moment. These are kind of the very start, the very preparation of some JSON file. And I can read the definition for the metadata from the disk, okay? This is very useful, because every time you run a service, you don't want to mess up in recalculating everything. You just deserialize the stuff. And then when you want to prepare the things, you just say, okay, in my domain context, we will see what I mean for domain in a moment. When I want to map an order as a source type, I have these two meta type definition, and I want to write this file with the metadata that represents the mapping. Okay, and in this other direction, I save to a different file. And be careful, because the transformation are not exactly the same. So when you go in one direction, you can go back with different mappings, and there are reasons for this. And so I saved one way and going back in a different order. And when I calculate these mappings, by the way, you have to know that the target, so who is, I didn't specify that I want to map order to online order. So the beauty of the system is that he will find that this type is the best fit for the order in order to translate. So this is why it is an order to online order. This M2 specify the complete list of the target data types, okay? And this is a preparation phase, nothing more. And once you have prepared all the things, you basically end up, and we will see, for example, we can either run the serialization or the deserialization. I mean, the serialization is, I mean, has a small advantage in my code because it's the last that I wrote, and so I will run this one, but it's very similar. It depends on what you want to obtain. And once we run it, I will show you exactly under debugging what is happening here. I just loaded the files. I deserialized this domain that we will talk briefly in a moment. I deserialized the mapping. This is specific between online order and order. You see that I want to transform an online order to order. Okay, this is a specific mapping. I prepare the JSON option, which is just specifying a converter that has the knowledge of mapping, okay, which is pretty simple. And then I load some sample data. Okay, so this is like on an online order with order lines, and I have some things about the food and a few other things. And at this moment, I can serialize straight in a different model using this JSON option that contains my converter. And as you see, I enter this semantic converter of T converter, could generate dynamically the code. And if I open the expression I can view, you can see the code that is generated specifically for those two types. And this is extremely performant because it's code generated. There are no ifs, there are no things. And it also contains the conversion of types that may be required in order to convert, for example, an expiry date from datetime offset to datetime, for example, because this is in datetime offset and this is converted to datetime. And so I have helper classes to ease the conversion, but there are no boxing and unboxing operation. There are no glitches. So this is very, very, very fast. And once I have done this, I end up in serializing, and you see that I have the JSON. If you want to see it better, we can use a different viewer. So we use the JSON serializer. You see order items, and this is different. This is a different structure, right? And in order to give you the proof that this is good for my object, I try to deserialize without any option, so a straight serialization, the serialized orders into an array of order using the standard serializer. And so you see, I had here online orders. Okay, these were online orders. And I serialized and obtained a JSON that has the shape of the orders. And as soon as I deserialize with a standard serializer and an order array, I obtain the data. And this is exactly what I expect too. So this is the magic behind this stuff. So this is also very nice, also because the delegates that uses this stuff are entirely cached. So once you generate the first time, you don't have to spend more time in the code generation. And the whole process is very neat. we have to now shift the discussion to how can I generate the mappings, right? If you are brave, you maybe want to generate it by hand, but I will not suggest you. And then I want to give you additional advantages in using another process. So the main goal is the one that I just showed you. And since you are using metadata, you don't have to restart the client. You don't have dependencies on any assembly, and you get rid of it. So another good reason to use this system is that maybe in event streaming, you have old slices of serialized data that comes from the past. And I mean, there are many different strategies to avoid the versioning issues with event streaming, and I don't want to enter in it. But alternative scenarios are the ones that use queues. So if you have a queue that has been saved and it contains some data, and you want to restart it later, for some reason you have to run this queue once a week, for example, every time you update a version of a model, you end up in having these issues of versioning, because maybe you updated the version, but that in the queue is still old. I mean, it's a nightmare. It's really difficult. So the semantic driven modeling substantially introduce a new abstraction over the public model exposed by the service. So the service contract does not depend anymore on the model, but on this conceptual model, which is different. And now we will see a DSL, so a domain-specific language, very simple. It's just text with a few words that will drive through the creation of this metadata. So the idea is to make this mapping easy. So I created the DSL. The DSL is created as the compiler, let's see, as a
Hey, Rafa, just a second. Yes, you're back online.
Sorry, what's up?
All right, now I shared your screen again.
What's happening? Sorry, I didn't get your words.
I was saying that yeah, it disconnected for some reason. I mean, you just dropped off, but I shared your screen again, and I don't know, just the last minute was cut off.
Okay, should I go back from one slide or what?
Yes, that's good enough.
Okay. Okay. So basically, I was said that you was here and something happened during the streaming. So I will restart here. But if you have questions on this, you can ping me also later. So basically, I decided to take the strategy of creating a DSL, domain-specific language, which use a C# code generator, which is in .NET 5 and Visual Studio. Basically, you'll just write this file, which is very simple. We will see, we can see it immediately. So it's extremely easy to define. So let's say that you have this. This is a comment. This is the concept, and these are the synonyms that you can use for a quantitative measure. Or maybe you want to express, let's say, something more interesting. Document. And we know that a document can be called the invoice or bill or certificate, receipt and record and so on. So these are synonym. And we have a few other parameters, and go back to the slide, that can give you a more precise idea of what you are meaning. For example, when you say gross, I want to keep the information that gross is a gross weight and is not a net weight, because they are both unit of mass, but they express different things. So you can think of this is the concept, and this is the second order concept. And then what about load? Load is like item or generic terms, is not very, I mean, they are not very precise. And so I can say, okay, if you use load in the context of the product, because maybe the class name is named product, or maybe the parent class in the graph is named product, you know that load is referred to unit mass. Otherwise, it's something else that must be defined elsewhere in the DSL. And this weight can give you some weight in order to process and have more probability to assign this term to unit mass instead of others. And the other are just comments, so it's not very. It's just for cosmetic purposes. Once I collected and wrote this file, I can just link together, and the DSL does this automatically, linking terms, concept specifiers, and weight, and produce exactly all that is required to define a domain. And the domain is important because I don't expect to be able to describe an ERP domain, for example, that is valid across my model and your model, because maybe we have assumptions that are different. So if I define my own domain and I use this system, this entire SDM in my environment, I can make assumptions like, I always use SI unit of measure and not imperial. Or maybe all my unique IDs are integers or are GUID. Or maybe I want to propagate the GUIDs having the same ID in all the graph when the ID serialize, so that I know exactly, and I can find the object more easily on the database. And I can enforce validation in unit testing about the use of a given concept. For example, every time I use one of the weight words, like load, for example, they should be expressed using decimal data type. And this is important because many times I have seen in my life assisting people that use different data types in the same model, and this is a mess. I mean, but you can have a rule that say all the concepts should share the same data type, and with just a rule you enforce a huge deal in having consistency across all your model, which is extremely good. And also, you can express the semantic metadata on the boundary. This is extremely important because instead of having a rigid schema like open API or other models that you want to have, you just express the semantical metadata that tells you, hey, you know what? In this endpoint, I have my parameters that express those concepts. Nothing else. I don't care about the rest. I want to be sure that if you want to find a product inside the parameters, you will find it. And these metadata just tell you how to find and how to map automatically onto your own model that has been designed with the same principles, of course. This is why we have semantic driven metadata. And the whole set of terms, concepts, and specifier and weights can be shared and can be also improved over time. If you have new terms that you want to use, if you want to introduce new concepts, you are free to go. There is nothing preventing it. It's just something that you can deserialize. And the rules, the validations, and so on is not just something that is happening at runtime. It all happen and during the developer time, so in unit testing, so you don't have to waste time in production. This is a different, totally different, I mean, design principle in comparison to the model where you have like validation happening at runtime and so on. Of course, they are complementary. They one that cannot replace the other. They are different. If you want to validate the object at the very end, once that everything has been converted, you have to do, of course, but it's totally different meaning. And I mean, one of the things that I want to point out is that the content time negotiation becomes very important. So, of course, the standard, we know the standard is type, subtype, parameter equal value. And one hypothesis I made that I am still experimenting is saying, what about if I have a domain in the IoT space that I created, so it's just my own in my distributed application with 100 small devices, when 100 Arduinos that push data, push temperature data on a queue. And I could use the application semantic.iot plus JSON, so that the JSON serializer knows that can enter in the space, specifying what is the domain, so that I identify exactly the terms, the concept, and the specifier that I defined, and then also the version. But because maybe I need in the future to change entirely the semantic of my space. And this is a kind of possibility that we have in the handshake once I want to obtain something from the service. You may think, what about the endpoints? So when you try to consume like a GitHub API, the first very thing that you have to know is the name of the endpoint, right? And they can also change over time. So this is another issue. But there are two things that I have to say. First, in the initial dissertation of the REST API, Fielding said that the endpoints should be discovered. Well, he also said that the resources can be discovered, but we know that the resources, which is the public model, by the way, is something that is so much difficult to discover, because you have to examine, you have to waste a lot of time in examining the data that is coming out, and basically you cannot do anything about it. So the alternative of this is, say, the endpoint is important and can be discovered. There are no specific issues why you should not rely on the hypermedia view of the web to discover the endpoints. And also, there is another interesting point, that if you want to version endpoint, you can just use a redirect. I mean, they are not so difficult to deal with. Anyway, if you want to apply the same principle of the semantical meaning of on the name of the endpoint, of course you can. I have few ideas on that, but I don't want to put too many things at work at the moment. So in the current code that I just have on my PC, by the way, but it will be published soon freely. This is something that I want to deal with, but at the moment the current implementation only deals with the public model and nothing more. So just to be very precise on it. And what about the GraphQL? The main issue with GraphQL, which is great, I mean, it's fantastic, is that you preserve the data structure. So the graph is exactly the one of the producer. So you can just cut your leaf. You can cut a piece of the graph, but you cannot change the graph. And so if it's just a problem of cutting the path, as I said before, I mean, it's easy, because if I remove the path from the mapping, the data is not copied, and you basically have GraphQL. It's just of, I mean, maybe there is the requirement on formalizing what are the path that you want. But as an additional advantage, if you use SDM, you have the remapping on your own model, which is far better. I mean, this is a matter of, but anyway, let's say that I want to stick with GraphQL because it's good, I loved it, and it works, the performance are good, and so on. You can use SDM on top of GraphQL. There is nothing preventing doing it. So it's, I mean, it can replace it, but it can also sit on over the top. And I mean, in every case, in this case, as soon as you use SDM, you don't need the DTOs anymore. You don't need to convert the data types. So if you have questions, I will be more than pleased to discuss them with you. And we can also go straight to the code if you still want to see something. Dan, are you here? Florin, are you there? I hope not to have lost you. Hello, hello. Now I can hear you. Okay. So we are at the Q&A. I don't know if someone already posted something for me, or maybe you.
In the chat. But first of all, I want to say thanks for the great presentation. I think you combined, let's say, a real issue with your passion for code generation. And,
yes, of course. So,
and don't worry about questions. You know, I always have questions. We started with all sorts of questions for them, so no worries.
Of course,
there are questions before. But let's start with this one then.
So, for example, meanwhile, I want to show you the generated code, the automatically generated code from this text. The DSL produced this stuff, for example, or this other stuff. So there is a lot of generated code, of course, and writing this is a mess, but writing this is pretty easy. That's the point. So tell me the question, please.
All right, I can also let me know if you also see it on the screen.
Oh, maybe I can just open it. If you want, I can stop sharing so that I don't bother you with Okay, let's start. Okay, I need to deserialize the product ID into product.id and product name, which means I need to call the product service with async HTTP get call, okay, to get product details. Is it possible while this is sync serialization? Oh, well, the serialization is always synchronous, let's say, because of course happen in the context of the infrastructure. You don't need to change anything in your actions and your controllers and so on. So your controller stays async. There is no need to do this differently. And you have to just plug in the infrastructure from the startup CS, the serialization options of this JSON serializer. So I just need to plug in a JSON converter, custom JSON converter. At least it's a JSON converter factory, because of course have to generate different JSON converter for each data type that you want to convert. But that's it. I mean, it's exactly what is meant to do. So the answer is yes. You can use this this way, and it's pretty easy. I am still working on a way that make the whole preparation easier. So it's easier to deal with that. The generated code was not visible. Okay, I can
you share
absolutely share again everything so that. Okay, can you see that?
Yes.
Okay, so basically the starting point is, as you see, let's do the things the right way. So I have this, this is a normal class library and nothing particular. There are a few references and a few obsoleted stuff because I'm working on it, but it's very, very standard. The only thing that you have to add that is very important is this semantic glossary generator inside the analyzers. Okay, this is the way the C# code generators work in .NET 5. So nothing specific to my own project. And this is an so-called additional file, and you can see here C# analyzer additional file here in the properties, which has this strange syntax. I invented it. Maybe, I mean, can be better. Probably yes. I don't know. I mean, I don't care too much. As you see from the length of the file, it's pretty short. Okay, so at the very beginning, I wrote a lot of comments, and you see there is also wraparounds in my editor. So, but the very start is line 43, and these end up in 319, and you see they are pretty easy. How do you come up to these terms? So these words can be extracted from your own code if you want. So I plan to write a tool that take by reflection all the terms from your class name and property name, and then creates a flat list of words. And once you have that, you can simply group them by meaning, by concept, and write the concept on top of it. Like validation, the concept of validation is with valid, is checked, and control and check. This first parameter is the context, as I explained before. So check is a validation only in the context of product. That's a simple way. Or another interesting is that minimum is a bound, but also even maximum is a bound. So I don't want to confuse minimum and maximum. For this reason, I added a concept specifier using the square brackets, specifying min and max. And this may give me the opportunity in my abstraction to distinguish this concept of bounds from this other. And you can put as many as you want. I mean, it's just a way to classify the terms that you use in your property names and class names. I specifically avoided the need to adopt attributes or things like that, because I don't want to mess up my model with attributes first. And then also I want to be able to maybe map even a model that was not prepared for that, but that is decently written. And so if it just expressed the things in the right way, I can just analyze, put maybe some exception, or code some rule that can give me the right decision for the mapping, and then go on. And the generated code is under this node. And you can see there are one for each parameter. So the terms are the second parameter here. And then we have the concept is this one, the first, the heading. Then the concept specifier, the one in the square brackets. And if we look at them, we can see the definitions. They are strongly typed definition, very simple. you see that the list is long. I mean, writing all this stuff is boring. And then the concept, it's very similar, okay? There are fewer, of course. And then the concept specifier, and there are even fewer. And this is it. At the very end, the domain is the one that puts everything together, that links one with each other, with the others. And you see the list is very long because we have many terms. But I don't want you to write this. I mean, you already have all this stuff. You just have to write this text, and then you can generate everything using the code that I showed before, which is pretty straightforward because in the deserialization here, at the very beginning, we prepared the domain. This is the class that I just showed in 1 second ago, okay? And there is a base class, which is domain base, which already defines few things that are pretty common, like ID, unique identifier, this name, and things like that, which is pretty common. And then I serialize it. And then I analyze the first domain, which is composed by these types. And what I am doing here, I just visit all the graph, and then I serialize the result, and I save here. And I do the same for the other domain, so the source and the target. And then again, this is the time for mappings, and I say for every mapping, like order or online order, I create a different mapping. So this is the source model, the one that we just created here. This is the destination, and this is the class where I want to start from. The target class will be automatically picked up from the system. So what is possible to do, and so I came back to the camera, is that you can build a UI on this so that you have a kind of designer that you use during development time when you import all the metadata and you ask the system, please map them. I don't want to bore. And if you have some I mean, overriding rule that you want to apply, you are free to go. I mean, I don't want to force you over a given map. And if you want to take control over the conversion, because maybe you want to do a conversion that uses a formula, right? Or things like that, you can hook the conversion and you're done. And also, there is a specific point in my algorithm when I am weighting. I mean, I have a scoring algorithm basically. So I order all the mappings and seeing what's the highest score, so that I can map A to B. So the source property to the target property. And if I have equally scored mappings, the UI can show it because there is a specific hook for that. And so you can have a combo box, for example, where you pick the one that you prefer and you're done. So there is a lot of work that I have to do in order to make it a product, of course. But I really want to demonstrate that it is possible to completely getting rid of the public model on the service boundary. This is the main point.
Okay, Raffaele, very in-depth. So I think it's time to have a short break. But before that, thank you once again for the Codecamp, and really looking forward to, as you mentioned, having you back in person.